In this video, what we're going to do is we're going to revamp the wandering state so that it no longer worries about using navigational nodes, but we are now going to use a navigational mesh or a pylon that you can place in the maps. Now what the pylon does is when you place in the map, you can put multiple pylons, but in our case we're just going to have one. But what the pylon does is it allows the AI to move along it in any position that it's allowed to move. So in the case of the escape map, which we'll be adding, the pylon fills up the whole map. So when the AI is in there, it can move in any location outside of obviously areas that's not allowed to go, which have blocking volumes. Okay, so what we're going to do is we have two vectors here at the beginning. We have variable vector nav goal location and next location to goal. Nav goal location is the goal. It is the end point. It's the moment when you finished your path. So if the AI starts at the far right corner and it's trying to get to the opposite end, the goal would be the opposite end. The next location to goal is the path that it takes to get to that opposite end. Sometimes you can't go from point A to point B. Sometimes in order to get to point B, you also need to hit other points along the way, and that's kind of how this works. So we have those two vectors which hold that information for us. Then we're going to go down to our wandering state, and we start off with function C player. We're not going to change anything in this, and I'm not going to go over it because it's already been talked about. But basically, if the player sees the enemy or the AI sees the enemy, then it goes to the attacking state. Now, if you want to, you could comment this out, which would allow you to test it out a little bit easier than having this thing chase you around and breaking from its wandering state. So if you comment this part right here out, go to state attacking, at this point you can actually run the code and it won't attack you, and the creature will just kind of wander around. Now we have down at the bottom here we have begin state, and we're going to set nav goal location to equal pawn.location. So when we first enter the wandering state, we're going to say your goal is to go where you already are, basically. You're already at your pawn.location. You're already there. So, and the reason for this is because it gets things rolling. If you look at our begin label, the first thing we have is wait for landing. So if the pawn's falling for some reason, we want to make sure he's landed before we do anything else. And then it says if the pawn.reach point nav goal location none. So if the pawn has reached the goal location, which we set here, then go ahead and call on function get next random location. The none here is the pawn's anchor point, which we don't have to worry about anymore since we're using a navigational mesh, at least not in this situation. So we call on get next random location if we reach the point. So that's what's going to happen. Begin state sets this to this point, and then obviously the pawn will be at that location. So it's going to then go to get next random location. If for some reason it does not, if it's not at that location, then it's going to move to that location, and that location is called next location to goal. And the reason for that is because obviously you're not going to be reaching your nav goal location if you can't get there directly. And at that point you're going to need to get there through a pathway, which is what next location to goal is. It's our pathway that leads us to our goal. And then we're going to call on set next location in path, which basically we'll go over that in a second. And then we have done wandering, and we're going to sleep for a tenth of a second, and then we go back to begin and restart this thing all over again. Okay, so let's say that it starts off and we do hit nav goal location, which we will in the beginning. We go to get next random location. So let's go up there. And inside of get next random location, we have two static functions we call. We call one static function from a class called navmeshGoal_random. And what that is you pass in the navigational handle, and you pass in the minimal distance that you want the AI to move when this random path is created. So I put 256. So basically 256 units from point A to point B is the minimal. It could go up much higher, but that's the minimal. And that stops you from walking 10 feet and 20 feet and things like that. It kind of keeps the AI moving a little bit more. You could set this larger if you wanted him to go larger distances, every time. Then we have class navmeshPath_toward static toward point. Now the difference is the find random sets a goal, the toward point sets a constraint. And what the constraints do is they're basically like rules. As you're moving along this path, the rules that the AI needs to abide by. If you wanted to make sure that he stays away from certain areas or things like that, that's where you probably would throw in constraints and change things up and make sure like he follows a certain path that you want him to follow, not just any path. Okay, navigation handle dot find path actually finds the path. So it finds finds that path from that the AI is supposed to travel. Um, since we have a goal set and we have a constraint set, we don't actually need the constraint set, but it does help to have them. It allows this find path to fine tune from point A to point B, so that when the AI is moving from A to B, it follows the rules and gets to the goal. Okay, so once we have find path, we then can get our goal point. Because it's a random location, we aren't telling the AI to go somewhere specifically based off of our code. We're just telling them to go somewhere random. We have to find out where he's supposed to go because we have no idea at this point. So we set nav goal location to equal to the navigational handle path cache get goal point, and this will return the actual vector of where this AI is supposed to move, the final moment where it's supposed to move. Then we also set final destination to this nav goal location because that we need to set that so that the navigational handle understands that that is where our end goal is. That's where we're trying to get to when we're finally there, and that will allow it to reset things that need to be reset and understand that it can move on to move the code along, as opposed to just sitting there thinking, did we ever reach where we're supposed to go? If navigational handle dot point reachable nav goal location. Okay, so what we're saying here is if the nav goal location is reachable. So this is our check to see if when we know what our goal is, can we walk from there to it? Can we go from point A to point B without anything getting in our way? If we can, we set next location to goal equal to the nav goal location, because obviously if we can get from point A to point B, we might as well just walk there. Otherwise, if we can't reach our goal, then we need to find a way to get there. And the way we do that is we call on a function called getNextMoveLocation, and we pass in as an out parameter. So this next location to goal gets set by inside of this function. We don't need to set it outside of it. And we also set 40, which is basically the number of units that the AI can get within, to the point where then we're going to say, okay, you can now move on to the next location. So navigational.handle.getMoveLocation finds our next location along the path. Set next location in path is the same thing as this pretty much. It just, all it does is it gets our next move location. So when we go over this, what basically happens is when the game starts, or when the player originally goes back to its wandering state, the first thing it does is it sets the goal location to the pawn.location. It sets it because we're just trying to get the ball rolling. Now, if we had an actual goal that we wanted them to get to right off the bat, you could set that as well. But in this case, we just want to set it to the location of the pawn. It's going to hit there. It's going to go and find a random location at that point right away. It's going to go find a random location by using the find random, and then it's going to set the path. It's going to get the goal to the path. We're going to set the goal to the actual navigation handle. We're going to see if it's reachable. If it's not reachable, we're going to find the next location along this path. So the AI is going to say, oh, I can go to point C before I can get to point B, and then it's going to move to point C. And then what's going to happen is when it hits point C, we go back down here to our begin label. It's going to hit here again. It's going to say if pawn.reach location nav goal location none. So then it did reach it in the beginning. It calls this function. Then it moves through and it sleeps for point 1. So what's going to happen is the AI is pretty much going to do nothing at that moment. It just has its new location set. Then, because it's going to flip through really fast, it's going to say, okay, now that it has a new goal too, it's going to say, did it reach its goal? Well, obviously not. So then it's going to move down here, else move to next location to goal. So it's going to the AI is then going to move to its next location that it needs to hit. At that point, we're then going to set the next location after that, because move to is a latent function. None of this will move on until move to is finished. So it's not like it's going to get called all of a sudden out of nowhere. Okay, and then once it finds its next location and path, it's going to shoot back up. It's going to check, did we reach our point? If we didn't reach our point, we're going to move to that next location and go again. And then we're going to find the next spot in the path. And it's going to keep doing that. Now eventually the AI is going to reach its point. When it reaches its point, then it's going to find another random location and it's going to start all over again. So now when you have the pylon in the map and it's fully taking up its sections that you want the AI to walk in, the AI will now just kind of wander around throughout the whole map and walk around the maze. Even though there's many walls along the way, it'll walk around the walls without any issue. And that completes this video.